I think you'll appreciate how straightforward this lesson on solving inequalities with addition or subtraction is. You already basically know how to do it. But in order to prepare for the lesson, I would appreciate it if you would practice solving these three equations. So go ahead and pause the video, and then you can also fill in these too, actually, because if you know these, you are all set to go. So pause the video. Alright, and here that is. Go ahead and take a few seconds to look those over. Again, those three main ideas when solving an equation are going to come back today, because this is how you actually solve inequalities. Let's look at that more specifically then. Alright, we'll switch our directions here. Instead of saying when solving equations, we're going to switch it to when solving inequalities. And the handy part of this is I don't need to retype it, because these rules stay the same. When solving inequalities, your goal is to isolate the variable. The golden rule remains the same. Whatever you do to one side, you must also do to the other. And we're still going to use inverse operations to solve our inequalities. So if you need a little recollection to solve inequalities like we would have done with equations, you should distribute or combine like terms first if you have to. And then you use addition and subtraction to get the variable on one side. And then you would continue to use addition and subtraction to get the numbers or the constants on the other side. Alright, we're going to solve these problems together on this page. If you think you can work ahead of me, go for it and just listen to me in the background. Also, if you ever have any trouble solving inequalities, go ahead and just change those inequality symbols into equal signs until the very end. Don't forget to turn them back into inequalities. Alright, so we have x minus 3 is less than a negative 6, and our job is to isolate the variable, which is that x. The thing that is in the way of it being alone is that minus 3. So we're going to undo the subtraction by adding 3 to both sides, and we are left with x is less than negative 3. And then I wanted to practice graphing right away since we're on it. So negative 3 is an important boundary number. Go ahead and put a hashtag where that negative 3 would be, and then decide if your circle is open or closed. In this case, it's an open circle because we're not including the negative 3. And when we read it, it says that x is less than a negative 3. The values on the number line that are less than a negative 3 are the ones that are to the left. And so your arrow would go that way. Moving on to number 2. In number 2, I have some terms that are like terms, the positive 8 and the negative 3. And so you would start off by combining those. So 8 minus 3 is just a positive 5. And so simplify that part first. Now I need to isolate x. My positive 5 is in the way, so we will undo an addition statement with subtraction. Both sides, you saw the golden rule, and then 10 minus 5 is just 5. Put 5 down as your boundary number. This one is going to have a closed circle because 5 is included as one of the solutions. 5 is greater than or equal to 5. But so is 6 and 7 and 8 and 9 and 10 and all the way up to infinity. And so our arrow is going to go in that direction. Number 3 has like terms as well. X minus 3 plus 7. When we combine negative 3 plus 7, we're going to get a 4, so we have x plus 4 really, when that's simplified, is less than or equal to 0. Subtract 4 from both sides to isolate your variable, and hopefully you're getting the clue that solving inequalities is really simple once you've learned solving equations. And so we are at x is less than or equal to negative 4. Negative 4 is our boundary number. Decide if it's open circle or closed circle. Think about which numbers make that statement true. X is less than or equal to negative 4. And then shade appropriately. And we need to skip this last example until you have watched your video on solving inequalities with multiplication and division. So just leave that one and you can come back to solving that later.